working on part 3 today, but we have Monday to finish this up as well. And then we have this homework due tonight, although as I mentioned last time, it's primarily about part 2. So there's not really anything we're going to talk about today that you really need on that homework. So let's start by going over some of the things in part 2. In part 2, we were computing the consistency of these 5 events. And so we're going to use those exact same 2 rules that we saw in part 1 with one little minor change for the last one. So a little bit of review. We have that subset rule where the subset is usually the one with the smaller probability. And if you're not sure which one the subset is, you can always sort of use this trick. So like, for example, it's pretty obvious that a blonde male is a subset of male. And you can verify this since if you're a blonde male, then you're male, but not necessarily the other way around. Same logic works on these 5 events that we have. For example, if a stock price has decreased by 5% or more, then it's also decreased by 1% or more, but not the other way around, which means event 1 is a subset of event 2. So according to our rule, we know the probability of event 1 is less than or equal to the probability of event 2. Likewise, we get a similar rule between the 3rd and 4th event. And those are the only 2 we need to worry about in terms of this subset rule. Now, we also have this 100% rule, which says if you have a group of events where it's guaranteed one of them is going to occur and only one of them will occur, we can use this rule with these 2 events in the following way. So let's say the initial price of one share is $100. Well, the first event where the stock price decreases by 5% or more means the stock price lands somewhere over here. The 3rd event is that the stock price lands somewhere over here. Well, what else could happen? It's not guaranteed that one of these 2 things could occur. What also could happen is it's somewhere in between, right? Well, that is our 5th event. So this does follow our rule. We're guaranteed that either the price lands over here, over here, over here, and therefore the sum of these 3 probabilities has to be 100%. Now we could try to play the same game with events 2 and 4, but we kind of run into the same issue, right? It could be the case that it lands somewhere in between, like it doesn't change a lot, or maybe it doesn't change at all. But the stock price changing by a percentage between -1 and +1% is not one of our events. So we can't do this same trick that we did before. So the best we can do is say this. And this is something we have not talked about yet. Essentially, when you have 2 events that don't touch and only one of them can happen at the same time, the best you can really say is, well, if I add up these probabilities, I don't know exactly what they're going to add up to like before, but I know it's going to be less than or equal to 100%. Or another way of thinking about it is, if I add these things up, I can't go over 100%, right? You can't say, oh, there's a 130% chance that one of these 2 things happens. That doesn't make sense. So, summary. When we're talking about the consistency of these 5 events in parts 2 and 3, these are the 4 things we need to check. So for example, on the first question of the homework due tonight, when they say, which of the following is a consistent set of probabilities for these events? And you're looking at these 3 options, and you're trying to figure out which of these 3 options is correct. All you need to do is consider these 4 rules we've written down, and there's should only be one of these 3 that satisfies those. And then the rest you can eliminate because they'll fail to meet one of those rules. So that's the idea of that. And then as far as our spreadsheet is concerned, we can do the exact same thing we did in part 1, where we build a couple columns, one for each one of these rules that we just wrote down. And then it makes it a lot easier to answer. Okay, how many people make consistent predictions about the first 2 events? What about the second 2 events? So on and so forth. And then there's like another calculator that you're going to want to build for the homework as well, which is going to utilize this column, but you're also going to look at what sections people came from when they made those predictions. So in that case, it's still a counting function, but you're going to want to use a COUNTIFs plural because you're going to have two criteria. One criteria to check, what section they're in. Second criteria to make sure they were consistent. And that's part 2. For part 3, what we're going to do, if I move over to this occurrence tab for a moment, is look at these 10 numbers here. So what's going on here? So after these students all made these 10 predictions each, what happened was we waited like a month to verify whether or not these 10 events actually happened or didn't happen. So for instance, if we see a 0, these 2 events didn't happen. If we see a 1, these 2 events did end up happening. And so what that's going to allow us to do is go back to that raw data and say, oh, this person guessed that this was going to happen and it did happen. That's one correct guess. We're sort of analyzing, no longer analyzing consistency. We are analyzing how accurate the predictions were. And so our next objective is to measure this accuracy by what is referred to as the total squared difference. And there's this big long paragraph at the top of part 3 that describes this, but I want to go over an example anyway. So let's say I go back to the raw data and I single out this 14th person, and I'm looking at the 14th person's 10 guesses. What is the total squared difference? Well, what I'm going to do is I'm going to compare these 10 guesses to these 10 occurrences from the occurrence tab. I just pasted them over here so I could have them both on the same screen at once. And I'm going to do that in the following way. I'm going to take, let's say, their first prediction, and I'm going to compare it to the first occurrence. And the way we're going to compare it is we're first going to subtract them. That's called a difference. Then we're going to square this difference. That's called a squared difference. And so you're going to get 10 of these squared differences, and then you will add them up to get what's called the total square difference, a single number that tells you how accurate their predictions were. So if I did this by hand for person 14, I would take this 0.463 minus 0 squared, just like I have right there. Then I would take the second prediction, 0.934 minus 0 squared, plus the third one minus, now it's a 1. So it's not always minus 0 squared. Now it's a 1 squared, and until you get all 10 of these and you add them up, that is one total square difference, person 14's total square difference. Now, I want to compute this for everyone. So our first goal today is how can I do this efficiently, so you can not have to do this by hand. You want to utilize things like dragging and stuff. Well, here's a little hint, very similar to what we did in part 0. So, remind yourself what we did there to speed up that process. And that's one of the first things you're going to add on this calculator, a giant column of total squared differences. At least that's the end goal. You might have some other columns before that, if they help. Okay, so that's the first page of part 3. Then there's another question on the second page, which asks us to do the following. We want to take all of these predictions and round them to either zeros or ones. But I want to point out this very common mistake that people do. You do not want to use the increase or decrease decimal buttons. Don't use this, because let's say I go to this cell here and I round it to a 1. That's not actually a 1. Look in the formula bar. It still says 0.61 there. It remembers that. So when you use these buttons, you are not changing the value. It's just a display change that you're making. So what you need to do is, well, at least this is how I would recommend starting. Start by copying all of these labels somewhere, because we're going to change all the numbers in between. I don't want to mess up the raw data. So what I would recommend doing is copying all of this stuff to a new tab, so I don't have to worry about corrupting the initial data. And then we're going to go to this top left cell and use the round function, which actually rounds the numbers. And the way you're going to do that is once you are inside the round function, you're going to reference the original raw data, because remember, we didn't delete this, it's still there on another tab, and actually round that to a 0 or 1. And then this entire screen will be zeros and ones, and you're going to analyze it again for accuracy. You're going to say, oh, like this is a 0 and this is a 0. That's one correct prediction. That'll be like the idea there.